Okay, so welcome to section 10.2. Oops. 10.2, which is hyperbolas. Hyperbolas. Okay, so definition. What is a hyperbola? And sometimes it's given as an hyperbola. So an hyperbola. Hyperbola is the set of all points in the plane. So is the set of all points in the plane. Of all points in the plane. The plane. The difference of whose distances. The difference of whose distances from two fixed points. From two fixed points. Ugh. Two fixed points, and of course these points are once again the foci is constant. Okay, so what do I mean by this? I.e., let's look at the graph of a hyperbola. I feel like I've got spiders on me. Okay, so a hyperbola is like akin to, but not exactly like, but it looks close enough for our purposes right now. Two parabolas in a sense going in opposite directions, but they're not parabolas. Their curve is different, but it kind of appears as though they are. And there's going to be two foci, one focus here and one focus here. And for any point P on the hyperbola, the distance maybe I should do this dashed. So the distance from focus 1 to point P and from point P to focus 2 will be constant, namely point P to focus 1, and without the macron on top, that means distance, minus point P to focus 2 is going to be some constant K for all P's elements or points on the hyperbola. Okay, so theorem. We have two distinctly different types of hyperbolas, but let's go ahead and try and do it as one. So an hyperbola with center at h comma k, as is h comma k, horizontal, radius A, vertical, radius B, and foci at plus or minus c, from c equals to the square root of a squared plus b squared from the center. Notice there's no need for an absolute value sign because it's plus, not minus. So from the center are given by, and now we're going to have the two distinct definitions. Number one, up up-down hyperbola will be given by y minus k quantity squared over b squared minus x minus h quantity squared over a squared is equal to 1. Note that this is an up-down hyperbola, hence y, the term involving y, is written first. And it's positive, whereas the term involving x is written second and it's negative. So similarly, analogously, we have a right-left hyperbola. And of course, in that case, it will be defined with the x first. So x minus h quantity squared over a squared minus, sorry, that's a squared, minus the y term, y minus k quantity squared over b squared is equal to 1. So note, x squared is horizontal, hence right, left. Y is vertical, hence up, down. Where how do I want to say this? The linear asymptotes through the center have slopes m equals 2 plus or minus b over a. So let me move that down because it seems a bit too close to the definition above. So where, that's not what I wanted to do, it doesn't look good. Let's see if I can move this to where it's aligned. Okay, so where? Okay, so what does all of this actually mean? It's best to see it by example. So for example, plot the following hyperbolas. List their foci. THEIR, their foci. And plot the asymptotes. And plot their asymptotes. Okay, so here we go. Number 1. Let's say we have quantity x minus 1 squared over 9 minus quantity y plus 1 squared over 16. Oh, that's squared. Over 16 is equal to 1. So let's rewrite this. I claim that this is of the form x minus 1 quantity squared divided by 3 squared, from which I'm subtracting, and that's how we know it's a hyperbola, because we subtract quantity y minus a negative 1 quantity squared divided by, let's do this in pink, 4 squared, and that's equal to 1. So I claim that the center is going to be at positive 1 comma negative 1. I claim that A is 3, B is 4, so what is little c? Little c is going to be the square root of a squared plus b squared, so that's 9 plus 16. Notice I created that on purpose. So c is going to be the square root of 25, which is 5. Okay, since x first, where do I want to, what color should I use? I've used every color. Oh, I don't like that color. Let's use this one. X first implies right, left. Okay, so what I'm going to do, my center is at 1 comma negative 1, And I have slopes. Oh yeah, slopes. Slope will be equal to plus or minus b over a. So that's going to be 4 over 3. And I will show you where those come into play in a moment. So x and y coordinate axes. I know that this is right, left. And I'm going to the right one, so maybe I should have moved that a bit to the left here, maybe like so. Okay, and now something like so. So we have x and y coordinate axes. So let's do 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay, so the center is at 1, comma negative 1. Now there are 2 asymptotes through the center. They are from the center I rise 4, 1, 2, 3, 4, and run 3, 1, 2, 3. So I have a line that has a slope of positive. No, that's not it. Well, I guess I could use this and make it correct. There we go, 4. Oops, ooh, holy free holy. Okay, there we go, something like so. Let's make this a bit longer. Like so, something like that. Okay, so there's one asymptote. My other asymptote will be rise 4, run a negative 3. So I'll rise 1, 2, 3, 4, run a negative 3. 1, 2, 3. Okay, so my other asymptote will look something like so. But let's make this a bit longer. Okay, so now I know that this is a right-left hyperbola. So the only radius I use is the right-left one, which is 1, 2, 3 to the right, 1, 2, 3 to the left. If it were an up-down hyperbola, I would have used the 4, up and down, but it's right-left. So now I just create a hyperbola that is asymptotic to the asymptotes we just drew. Actually, maybe, I guess I could, these are terrible drawings. Let's see if I can make a better drawing with the, let's see, I'll make it, let's see if I can use this to make a better hyperbola. Kind of. I know these are parabolas, so they're not the best. So let me erase this because it doesn't curve back in. It just gets wider and wider and wider. Okay, so something like so. I'll erase this one and make a better one on the right. So let's make another parabola thing like so and then correct it. Okay, so we can now erase the parts that curve back in because it just keeps on getting wider and wider. It is not a parabola, it is a hyperbola. Okay, so something like that. Oh, we forgot the foci. The foci are at a distance of 5. So 1, 2, 3, 4, 5. And we always open towards the foci. 1, 2, 3, 4, 5. So the hyperbola is like hugging the focus, or the foci. It opens towards the foci. Oh, come on. Okay, well, note, not drawn very well. Okay, let's do another one. So number 2. Always open towards the foci. Okay, so let's say now we have quantity y minus 2 squared over 1. Or not, let me not even write it. Minus x plus 3 squared over 4 is equal to 1. So now rewriting this, I claim that this is y minus 2. Oh, oops, forgot to make that solid. Y minus 2 quantity squared over 1 squared minus x minus a negative 3 quantity squared over 2 squared is equal to 1. So in this case, the center is, now we have to be careful, center is h comma k. So it's going to be negative 3 comma positive 2, because x goes with x, y goes with y. Even though the y term is written first, that the grouping is still with the y coordinate is with the y and the x coordinate is with the x. Similarly, a is what's underneath x, which in our case is 2, and b is what's underneath y, which in our case is 1. Hence c, which is going to be the square root of a squared plus b squared, is going to be root 5, which is a little bit more than root 4. So root 5 is a little bit larger than root 4, which we know to be 2. So it's a little bit more than 2. But it's nowhere near root 9, which is 3. Okay, so we need our asymptotes, and so the slope of the asymptotes will be plus or minus b over a, which for us is going to be 1 over 2. And by the way, this was, y was written first. So y first. That's going to be an up-down hyperbola. Up, down. Okay, so let's go ahead and do this. X and y coordinate axes. Do I have more room? No, that's good. Something like so. Suppose x and y. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 2, 3, 4, 5. Okay. So my center will be at negative 3 comma 2. Through that center, I'm going to have 2 asymptotes, one with a slope of, maybe I could do it in the darker one, slope of rise 1, run 2, rise 1, run 2, rise 1, run 2, so it's going to look something like so. And the other with the slope of rise 1, run a negative 2, rise 1, run a negative 2, etc. So that's going to look something like, well, not very well. Let's see if I can do this. So I guess that's good enough for government work. Okay. And I know that this is an up-down hyperbola, so I'm going to use, of course I use, so 1. So I'm going to go up 1 and down 1. And I'm going to draw my hyperbola, which will open asymptotically towards the asymptotes, like so. And on the bottom as well, like so, and like so. Not drawn very well. I'm trying, but I am failing. Wow. Okay, good enough. Now I need to place the foci. The foci are at a little bit more than 2. 1, 2 and a little bit. 1, 2 and a little bit away from the center. So focus 1, focus 2. And there we are. We open towards the foci. Okay, let's do one more. So number 3. Let's say we have x squared minus y squared is equal to 1. So I claim that this is x minus 0 quantity squared divided by 1 squared, from which we're subtracting y minus 0 quantity squared divided by 1 squared. Oh, come on. 1 squared. And that's set equal to 1. Okay, so I claim that our center is at 0, 0. Our A and our B are the same, namely both 1, meaning that C is going to be the square root of 1 plus 1, otherwise known as root 2. 1 plus 1. And the slopes of the asymptotes will be plus or minus b over a, which is 1 over 1, which is just 1. But let me explicitly write that. 1 divided by 1. So rise 1, run 1. I know that this has x first. So that's up. So sorry, that's right, left. Right, left. Okay. So let's see what we have. X and y coordinate axes. X and y. Let's do 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so my center I know is at 0, 0. Through that center I have two asymptotes. One with a slope of positive 1 over 1. One with the slope of negative 1 over 1. So here's the positive slope of 1 over 1. And here's the negative slope of 1 over 1. So these are our asymptotes. We know that it opens right left, so I'm going to use A with a radius of 1 on either side to the right and left of the center. And I now open towards the asymptotes. Okay, we try to open towards the asymptotes. Okay, let's see. Okay, something like that. Now, where are the foci? The foci are at root 2, which is a little bit more than 1. So, like here, away on either side from the center. So focus 1, focus 2. Okay, so hopefully that makes sense. But now let's do the completing the square again. So for example, so put the following equations in standard form. Then plot. Okay, so number 1, let's say we have 9x squared minus 16y squared minus 36x plus 64y minus 172 is equal to 0. Okay, so I'm going to color code. So we have 9x squared minus 16y squared minus 36x plus 64y minus 172 is equal to 0. So let's group 9x squared minus 36x, to which I'm adding, or no, from which I'm subtracting. No, I'll add it and then I'll subtract it later. A negative 16y squared plus 64y. Now if I add 172 to both sides, this will be equal to 172. So let's factor out the lead coefficient. So 9 times the quantity x squared minus 4x. Now let's factor out a minus 16 from the next grouping. So this becomes a positive y squared, and a negative 4y is equal to 172. Let's go ahead and take half the linear coefficient. and square it in each instance. Oops. So the square of -2 is 4. And in the other instance, we're taking -4. Oh, it's the same thing. Well, that's going to be easy. So we add 4 inside each parenthetical. So this is going to be 9 times the quantity x squared minus 4x plus 4, from which we're subtracting 16 times the quantity y squared minus 4y plus 4. But whatever I add in, I need to subtract out. So I need to subtract out 9 times 4 and subtract out a -16. So let me just do -16 times 4 and set that equal to 172. So this now gives us 9 times the quantity x minus 2 squared minus 16 times the quantity y minus 2 squared. Let's see, 9 times 4 is 36. 16 times 4, 2 negatives make a positive, is 64. And that's 172. So we have 9 times the quantity x minus 2 squared, from which we're subtracting 16 times the quantity y minus 2 squared, is equal to. So 172 plus 36. Well, 170 and 30 would be 200. But I have a 6 and a 2, so it's 208 minus 64. Well, 200 minus 60 would be 140. But I was at 208, so that'd be 148 minus 4 is 144. Oh, that's a nice number. So we get 144. So now, since we want to put it in standard form, we always set it to 1. So let's divide each term by 144. Okay, and I know that 9 goes into 144 16 times, and 16 goes into 144 9 times. So this now becomes quantity x minus 2 squared divided by 16 minus the quantity y minus 2 squared divided by 9 is equal to 1. So we know that the center is going to be h comma k, 2 comma 2. A is 4 and B is 3. So together, C is going to be the square root of A squared plus B squared, which is the square root of 25, or 5. So that's a distance to the foci. We have that x is first, so we know that that is going to be right, left. The asymptotes will have slopes of plus or minus b over a, which is going to be 3 over 4 through the center. Okay, so let's go ahead and draw this x and y coordinate axes. Oh, nope, okay. Come on. So x and y have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, so we're at 2, 2. We know that through 2, 2, we have 2 asymptotes. One of rise 3, run 4. One of rise 3, run a -4. So we're going to have two asymptotes here. One kind of like that, and the other kind of like this. Okay, and since this is a right-left hyperbola, the only one I deal with is from the center. I'm going to go 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left, and I can draw my hyperbola. What color should I use since I've... what color? Let's do it in green, I suppose. Then I'll do my foci in a different color. So it's a right-left hyperbola, like so. Kind of trying to do this. If only there was an easier way. If only. And where are the foci? The foci are going to be at, let me do them in hot pink. They will be at a distance of 5, so 1, 2, 3, 4, 5 from the center on either side. So 1, 2, 3, 4, 5. There are the foci. Okay. Okay, so let's do the next one, which is number 2 on this question. So what do we have? We have 25y squared minus 9x squared minus 54x minus 306 is equal to 0. Okay, so let's color code here. We have 25y squared minus 9x squared minus 54x minus 306 is equal to 0. Okay, so it looks like y squared just has a single term, but let's factor out a negative 9 from the next two terms, giving us an x squared minus 6x. And let's add 306 to both sides. So now I'm going to take the linear coefficient of the blue, divide it by 2 and square it, so 3 squared is 9. So inside the parenthetical, I'm going to add 9. So 25y squared minus 9 times the quantity, x squared minus 6x plus 9. So whatever I add in, I have to subtract out. So I'm going to subtract out a negative 9, because that's what I have on the outside, times 9. And set that equal to 306. 306. Okay. So we have 25y squared minus 9 times what amounts to x minus 3 quantity squared, to which we're adding 81. Okay, so let's go ahead, copy these two terms. Oh, no, that's not what I wanted to do. Oh, shoot, I'm an idiot. Undo. Okay, wow. It's too late. So copy. Copy. Oh, leave a shot. Okay, so now what I'm going to do, I'm going to subtract 81 from 306. So if it were 300 and I subtracted 80, that would be 220. Now, if it were 306 and I just subtracted 80, that would be 226. But I have to subtract one more, so it's 225. Okay, so now I want to set the hyperbola to 1. So I divide each term in the expression by 225. Now, if I had 4 quarters, that's $1. 8 quarters is $2. So if I had $2.25, that's 9 quarters, right? So therefore, 25 goes into 225 9 times, and 9 goes into 225 25 times. So we end up with y squared minus quantity, x minus 3 squared divided by 25 is equal to 1. Okay, so the center, and we have to be careful again. In fact, let me color code it so that you see where I'm getting it. The center is at 3, 0. It's always x first, y second. So be very careful there. I claim that A is 5 and B is 1 because really there's a 1 underneath there. And 1 squared is 1. So C is going to be the square root of 5 squared plus 1 squared, namely root 26. So 25 plus 1. Well, root 26 is just a little bit greater than root 25, which is 5. So it's just a little bit more than 5. The slopes of my asymptotes will be plus or minus b over a, so that's 1 over 5. Okay, and this, what was written first? Y first. So it's an up-down hyperbola. Okay. So let's see, this is going to be an interesting looking hyperbola. Yeah, so x and y coordinate axes. You'll see what I mean once we actually do it. So x and y. Oh, shoot, ants crawling on my feet. Unbelievable. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. That should suffice. So we have 3, 0 is the center. Through that center, I have 2 asymptotes. Actually, let's make it the lighter one. Did I use the lighter one or the darker one? Okay. Okay, so I rise 1 and run 1, 2, 3, 4, 5. Or rise a -1, run a -5. So this is a very shallow line here. Asymptote. Similarly, going the other way, I rise a +1, run 1, 2, 3, 4, 5. 2, 3, 4, 5. Oops. Okay. So now we go up 1, because this is vertical, up, down, so B is 1. And we open up towards the asymptote. So this is a very, very wide hyperbola. It's curved, but very slightly. It's an exceptionally wide hyperbola. And the foci are going to be, let's do them in green, at a distance of 1, 2, 3, 4, a little bit more than 5 away from the center. 1, 2, 3, 4, 5, and a little bit more than 5 from the center. Did I do that right? 1, 2, 3, 4. No, this one is only a little bit more than 4. There we go. That's better. So notice the farther away the foci are, the more shallow the hyperbola is. I wonder if there was a way to make this easier. Stick around. I'll see you in the next section.